In this media, you will learn about multi-point flammable gas monitors. The main function of catalytic indicators and heated filament flammable gas indicators are for testing LNG tanks, enclosed spaces, and void spaces. These indicators are portable instruments that are used while performing gas-freeing operations. For spaces such as compressor rooms, machinery spaces, LNG holds, and motor rooms that are air-filled or air-ventilated, catalytic instruments are used in multi-point form. Catalytic instruments are installed on ships' bridges or in LNG control rooms in the multi-point form. The installed instruments take samples from the points under surveillance. The instrument monitors and gives alarm on detecting a low percentage of LFL, lower flammable limit. The catalytic type doesn't function at the void spaces that are inerted frequently with nitrogen. In such cases, an infrared analyzer is used as the central multi-point instrument. This diagram illustrates the principle of an infrared analyzer. For absorbing the infrared radiation, this multi-point instrument employs the property of hydrocarbon gas. The two nickel or chrome emitters encased within the instrument send infrared radiation to the two separate channels. Infrared radiations are sent through a reference cell free of hydrocarbons and a sample cell. A semicircular beam chopper driven by an electric motor alternatively blocks the two channels. The radiations transmitted from the channels pass through the detector cell. The radiations received by the detector cell heats the gas. The sensitive membrane of a condenser microphone detects the resultant rise in pressure. Because of the chopping of two beams and the absorbing effect of hydrocarbons inside the sample cell, the output of the microphone is an alternating current. This alternating current is amplified and recorded. The alarm is activated when a gas is detected. Thus, you have learned about multi-point flammable gas monitors. In this media, you are going to learn about the Coriolis mass flow meter. It consists of two parallel tubes, one driver, and two sensors. Driver is used to give mechanical vibration to the tubes. It consists of two brackets, namely A and B. Bracket A has one magnet fixed to it. Bracket B contains a coil, supplied by 50 Hz supply. Bracket A and B are relatively movable. Each sensor consists of a magnet and coil. Sensor magnets are connected to bracket A and coils are connected to bracket B. When an alternating supply is given to the driver coil, it attracts and repels the magnet as the cycle changes. This will cause relative movement between brackets. Due to this relative movement of brackets, the flux linking with coils in the sensor changes. This change in flux linkage causes induced EMFs in the sensor coils. When there is no flow in the tubes, mechanical vibration produced by the driver is identical at two sensing points. Due to this, induced EMFs produced in the sensor coils are same. So, the difference in these EMFs is zero, and it does not produce any output in the meter. Now, consider the fluid is flowing through the tubes. Because of vibration generated to the tubes, the fluid inside of the tubes will produce an inertial force. This inertial force, or Coriolis acceleration force, produced in the fluid depends on mass flow rate of the fluid. This additional inertial will cause different induced EMFs in two sensing coils. So, The difference in these EMFs will not be zero, and this voltage is graduated in flow rate in the scale of the meter. In this way, we can measure the mass flow rate of the fluid. Thus, you have learnt about Coriolis mass flow meter. In this media, you will learn about level alarm and automatic shutdown systems. An independent high-level sensor must be compulsorily fitted in every LNG tank except Type C tanks. The sensor should have the ability to give an audible and visual alarm. They must also have the capability of automatic stopping of the LNG flow into the tank. These independent high-level sensors can be of float, ultrasonic, or capacitance sensors. If the valve stopping the LNG flow shuts quickly, there is a chance of high rise in the pressure. Thus, you have learned about level alarm and automatic shutdown systems. In this media, you will learn about catalytic instruments. This diagram shows a basic electric circuit, Wheatstone bridge, of a combustible gas indicator. The sensor filament of the combustible gas indicator sucks the gas. The sucked gas gets heated by the bridge current and burns catalytically. Even if the gas has a lower flammable limit, the gas burns on the filament surface. This process raises the temperature of the filament, resulting in the increase in electrical resistance. The increase in the electrical resistance unbalances the bridge. This imbalance indicates the amount of hydrocarbon content in the air. Catalytic instruments indicate flammability, and the catalytic instruments can also be used to find the presence of gas in air. The meter scale present in the instrument can read from 0% to 100% of the lower flammable limit. The batteries contained in these instruments must be checked before use. Checking the instruments using a calibration gas at frequent intervals is a recommended practice. The instrument manufacturers provide a calibration graph for the instruments. The meter readings should be within the range indicated on the calibration graph. This type of meter shows a low or even zero reading for the tank spaces containing atmosphere above the flammable range. When the sample is detected by the meter might show a momentary strong deflection, but after that it comes down to steady, low or zero. The steady reading can be misleading, and hence the momentary deflection must always be considered important. The momentary deflection can also be an indication that the gas being sampled is above the lower flammable limit. Certain instruments also have sensor filaments. The presence of other gases, like halogenated hydrocarbons, may spoil the catalytic action of such sensor filaments. Digital gas analyzing instruments are also available in the markets. The batteries contained in these instruments should be charged only in gas-safe areas. Thus, you have learned about catalytic instruments.